Good evening, GCC math class. How are you this evening? We're going to continue looking in chapter 6. Tonight we're going to look at the properties of logarithms. So we've been looking about what a logarithm is, looking at the graph of a logarithm, rewriting between logarithms and exponential form, very important part of the lesson. Make sure you can rewrite between logarithmic and exponential form. In the previous night's homework, 6.4 homework, you spent a lot of time doing that because that's an important skill. Now we're going to take a look at the properties of logarithms, which will lead us into why logarithms are so important because of the things that they do. Now, I want to tell you that these properties are really counterintuitive. And what I mean by that is they really don't act the way you think that they should act. For example, let me show you the first 3 rules. The first rule is what we call the product rule. And think about multiplying logarithms. And this one says that if I have the log base something, I'm going to call it a, of a product, x times y, that's the same thing as log base a of x plus log base a of y. So the log of a product is the sum of the logs. And this might not make sense at first. It certainly doesn't. For example, if I had log base 2 of 12, that would be the same thing as log base 2 of 4 plus log base 2 of 3. Why? Well, because 12 is 4 times 3. The product of 4 and 3 is 12, so I can rewrite 12 as 4 and 3. I could have written it as log base 2 of 2 and log base 2 of 6. 2 and 6 would be another way of writing it. So that's product rule for breaking up a product. Next we have quotient rule. And we know that the quotient is the math term for, think of dividing. So if I have log base a of a quotient, x over y, where a is a number, x and y can be anything. They can be numbers or variables, whatever. The log of a quotient is the difference of the logs. For example, if I had the log base 2 of 7, I could rewrite that as the log base 2 of 14 minus log base 2 of 2. Well, where did this 14 and this 2 come from? Well, I can write 17 as 14 over 2, the quotient of 14 divided by 2. 7 is the same thing as 14 over 2. So if I write 7 as 14 over 2, then I can write log base 2 of 14 minus log base 2 of 2. And then the third main property is the power rule. And the power rule deals with taking the log base a of something, x to the power of n. So I've got log base a of x to the power of n. I can rewrite that as n times log base a of x. For example, getting close to the bottom of the page here, if I have log base 4 of 36, well, 36 is the same thing as 6 squared. And if I think about 36 as 6 squared, the n is the 2, I can rewrite that as 2 times log base 4 of 6. The 36 is 6 squared, and I can bring the 2 out here. A power to a power, we multiply. So these properties are very counterintuitive, and there is a reason that they work like this. It has to do more with exponents, rules of exponents. When multiplying powers with like bases, you add the powers. When dividing powers with like bases, you subtract the powers. Taking a power to a power, you multiply. So that's kind of where that's coming from with these properties of logarithms. Now there's more properties. These are the big 3. Change of base is another huge property. We'll deal with that a little bit later after we play around with these for a little bit. There's some other things that kind of logically happen, logical conclusions of this. For example, let's take a look at some more properties. What if I had log base anything of 1? Well, what is this? Now, the a could be any number at all. log base 3 of 1, log base 10 of 1. Log base 10, remember, is the common log. Log base e, the natural log of 1. Well, I have to ask myself the question, this would equal something. Well, a to what power equals 1? Anything to what power is 1? Well, this is going to equal 0. Any a value there, it's always going to equal 0. What about if I had log base a of a? All right, so I'm going to ask the same question. A to what power equals a? Well, a to the first power equals a. What about if I had log base a of a to the n? A to what power equals a to the n? And as I'm doing that, that's really how we rewrite it, isn't it? Base to the power is the argument. A to what power is a to the n? This would have to be an n. And then if I rewrite this, a to the n equals a to the n. If I rewrite this, a to the first is a. If I rewrite this, a to the 0 is 1. So here we have 3 more properties. And of course, if this a was 10, common log, the common log of 10 is 1. The common log of 10 to the third power would be 3, and so forth. And same thing with natural log. If I had e's in there, natural log. What if I had, it gets a little confusing here, a to the power of log base a of something, I'm going to call it m. Now this is a to the power of. The whole thing up here is in the exponent. Log base a of m is in the exponent. So a to the power of log base a of m. As you can imagine, a to the power of log base a are going to cancel each other out, and I'm going to get left with just m. Again, these properties can be a little bit confusing, can be a little bit frustrating. Sometimes they don't always seem to make sense. If we look at natural log, if I take the natural log of e, what's that? Well, the natural log is log base e. Let me rewrite this. If I rewrite this, this is really log base e of e. And I ask myself, well, rewrite it. E to what power is e? E to the first power. So the natural log of e is 1, because e to the first power is e. When you see natural log, remember, it's always log base e. So all of these properties would work with natural log and with common logs as well. The textbook deals with proving these different properties, and I wouldn't spend a lot of time looking at the proofs. I don't usually do any, even in class when I'm working on them. But the properties are very counterintuitive. They're very, very frustrating, very difficult, very, very strange things. So what I'd like to do is I want to look at some sample problems that we can do, and dealing mostly with rewriting and using the properties. All right, so let's take a look at rewriting logarithms to expand. Expand means we start with one logarithm and then we want to use the properties to write it out as a sum and difference of a whole bunch of others. So for example, if I had log base a of x times the square root of x minus 1. So this whole thing is in my logarithm. And I want to expand this. I want to rewrite it. I want to simplify it. The first thing I notice is I've got a product. X times the square root of x minus 1. I can use the product rule on this, and it would become log base a of the first thing plus log base a of the second thing. Now what about this? Can I expand that? No, but I can rewrite this. Log base a of x plus log base a. X minus 1, the square root of that, is the same thing as x minus 1 to the 1/2 power. Square root and 1/2 power. Now why am I doing this? Because now I'm going to use that power rule. And I get log base a of x plus log base a of x minus 1, and the 1/2 comes in front. There should be a 1/2 in front of here. 1/2. Oh, I didn't leave myself much room there. But no, see, the 1/2 power rule comes in front there. So this is log base a of x plus 1/2 log base a of x minus 1. And can I break this up? And the answer is no. There is no sum and difference inside here. If it was the product, two things being multiplied by each other, then I can write it. Let's take a look at another one, and the idea here is to expand these things. I'm going to pick one out of the exercise set, similar to some of the ones that I've assigned you to do tonight. And I'm going to pick, let's see, we just did one, you've got to do 49, we just did one that's very similar to 49. Let's see, how about, let's do number 52. And 52 looks like this. The log of x cubed times the square root of x plus 1 over x minus 2 squared. So a big expression here. A lot of stuff going on. Very complicated. And we want to break it up. And I want to break it up into a whole bunch of different logarithms, sums and differences. So this is very similar to ones that you're going to see in the homework tonight. The first thing that occurs to me is I've got quotient rule going on. Oh, hey, what's the base here? There's no number here, so it's automatically log base 10. Okay, this is common log. First thing I got is quotient rule, so I'm going to break it up using quotient rule, and I'm going to get log, common log, of x cubed times the square root of x plus 1 minus the common log of x minus 2 squared. Now I notice that I've got product rule right here. X cubed times the square root of x plus 1. I'm going to break that up. And I'm going to get log of x cubed plus the log of the square root of x plus 1 minus the log of x minus 2 squared. Now there's no more products or quotients that I can break up, but I've got power rules. Log of x cubed. The 3 is the exponent. I can bring the 3 in front, and I get 3 times the log of x plus, remember the trick here, the square root of x plus 1 is really x plus 1 to the 1/2 power. Bring the 1/2 in front, 1/2 the log of x plus 1 minus, there's my exponent, use the power rule, 2 times log of x minus 2. Now, can I break up x plus 1? No. X minus 2? No. I can't do anything. I can do products and quotients. I can't do sums or differences. This is my final answer. And you might look at this and think, well, this is far more complicated than that. And in some ways, you're right. But later, we'll see that this can be used to take functions that are big, horrible, nasty, ugly functions, very difficult to work with, and we can use properties of logarithm to break them into a whole bunch of smaller parts that are much easier to deal with. That's the whole purpose. That's what makes the properties of logarithm so important and so valuable to us. So this is using rewriting logarithms to expand. Now let's take a look at rewriting logarithms to condense. And so the idea here is that I want to take something that's got a whole bunch of logarithms, and I want to write it as a single expression. Again, I'm going to do an example out of the exercise set. You have to do 57 through 69 odd, so I'm going to do one of the even numbered problems. Let's do number 68. 68 is 1/3 log of x cubed plus 1 plus 1/2 log of x squared plus 1. And how many terms do you see here? How many different logarithms are there? How many terms are there? There are 2 terms, this term and that term. And I want to condense them. one of the most important things is the logs have to have the same base. Both of these are common logs, so I will be able to condense them, combine them. But before I use the product rule, I have to deal with the powers. So I'm going to rewrite the powers here. So this 1/3 is going to come up here. The 1/2 is going to come up here. Well, what is something to the 1/3 power? Really, it's the cubed root, x cubed plus 1, plus the log of x squared plus 1, the square root. So 1/3 is cubed root, 1/2 is square root. Now I don't have any other powers to deal with. I can combine these using my product rule, and I will get the log of, I'm going to have the cubed root of x cubed plus 1 times the square root of x squared plus 1, but the whole thing is now in one logarithm. It's all the log of one thing altogether. Could I multiply these out? Well, cube root and square roots, 1/2, 1/3, oh gosh, that would be very awkward to do. It would be better to leave it in that form, I think. So combining logarithms, let's do one more that's got a little bit extra going on it. Let's do number 62. Also out of the exercise set, similar to the ones that I want you to do, the log of x squared plus 3x plus 2 minus 2 times the log of x plus 1. And again, I want to condense. I want to combine these to rewrite it as a single logarithm. The goal is to rewrite it as a single logarithm. There's no power rule I have to deal with here, but I do have this. I'm going to have to bring the power up there. So my first simplifying step, I'm just going to deal with that 2. And I'm going to have the log of x plus 1 squared. No more power to deal with. No, now I've got difference. How can I combine them into a single log? It would be the log of, this would be in the top, this would be in the bottom. In other words, x squared plus 3x plus 2 over x plus 1 squared. Now notice, it's not log in the top and log in the bottom. It's the log of that, the quotient. The log of the quotient, if I work backwards, is the difference of the logs. So there's only one log here. There's not a log in the top and a log in the bottom. And am I done? Well, it occurs to me that this will factor. I can actually do a little bit of algebra here. The log of x squared plus 3x plus 2 is the same thing as, can I think of two things that multiply together to give me 2, add up to give me 3? How about x plus 2, x plus 1 over x plus 1 squared? And this is interesting because now I'm going to get some canceling. I've got some simplifying I can do. I've got an x plus 1 up here and an x plus 1 down there will cancel. And my final simplified answer is the log of x plus 2 over x plus 1. That's my final answer after all the simplifying is done. Okay, so these properties of logarithms, really counterintuitive, can be very frustrating, very difficult, really annoying. They don't seem to always work the way you think that they should work. In the first parts of the homework, you're going to use properties of logarithms to find the exact values. Let's do simplify. Let's do a couple of these. Let's do number 16, which is the natural log of e to the square root of 2. Well, and it's all about properties of logarithm. These ones we don't need a calculator for. We certainly don't need a calculator. So if I look at this, natural log and e cancel each other out, and I'm just going to get left with the square root of 2. That's going to be my final answer. So it's all about the properties of logarithms. If you recognize the properties of logarithms, then it's really easy and nice to do. All right, let's take a look at number 22. Log base 8 of 16 minus log base 8 of 2. All right, so there's no powers that I need to deal with. There's same base, so I'm going to rewrite it using the quotient rule, and I get log base 8 of 16 over 2, which is log base 8 of 8. 16 divided by 2 is 8. And what is log base 8 of 8? 8 to what power equals 8? 1. Log base 8 of 8 is 1. My final answer there is 1. Log base 8 of 16 minus log base 8 of 2 is 1. I know they can be quite counterintuitive, can be very frustrating. All right, let's maybe do one more of these. I'm trying to pick an even numbered one. This is where I would ask you to kind of look over them, see if there's any ones in there that look at you, that jump out at you, is giving you a hard time. Well, I don't know. The rest of them seem pretty straightforward here. Let's maybe 14. Gosh, without having the feedback, I really don't know where to go. 2 to the negative 13th power. And then, I would be looking for feedback and, are we getting these? Okay, great, I can move on. If not, let's do a couple more. And which ones do we need to do? Log base 2 of 2. Again, in effect, these cancel each other out, and I'm just going to get negative 13 as my final answer. Numbers 29, 31, 33, 35 are using some special properties of logarithms. Let's do one of those. So, and it says that that a is equal to the natural log of 2, and b is equal to the natural log of 3, and it wants me to rewrite things like the natural log of 2/3. Well, the natural log of 2/3, I can use quotient rule and write it as the natural log of 2 minus the natural log of 3, but the natural log of 2 is a, minus the natural log of 3 is b. So my final answer, I want to rewrite everything in terms of natural log of 2, natural log of 3's, and then substitute a's and b's. Oh, what problem was that? That was problem number 30 out of the exercise set. And then 37 through 49, expanding, 57 through 69, condensing into a single logarithm. And I think that's it for properties of logarithms. There is one more property that we need to look at, and I wanted to deal with this one completely separately. And it's something called the change of base formula. In the first sets of homeworks here, 6.1 through 6.4, we've been very careful to only give you sample problems where all the numbers turned out to be nice and well behaved. There wasn't really weird stuff here. But what about if I wanted to solve something like this? Solve 7 to what power is 10? Oh gosh. So if I look at this, 7 to what power is 10? Now think about this exponents. Can I rewrite 10 as 7 to some power? No. I know 7 to the first power is 7. 7 squared is 49. 7 to the first is 7. 7 squared is 49. 10 is somewhere between 7 and 49. So x has to be somewhere between 1 and 2. But what? What is it? What could it be? And this is one where, as we look at this, there's no nice, easy, quick way of doing this. But if we use the change of base formula, and we're going to kind of derive that here. So let's go ahead and solve this one now and see what we can come up with. We know at some point we're going to need our calculator. The answer is going to be some number between 1 and 2, some weird number between 1 and 2, probably closer to 1, because 10 is closer to 7 than it is 49. All right, so what I'm going to do here is I'm going to take the natural log of both sides. That's kind of a key step here. Take the natural log of both sides. And when I do, I'm going to have the natural log of 7 to the x equals the natural log of 10. I'm not multiplying both sides by natural log. I'm taking the natural log of both sides. Well, how does this help me? This seems to be even more confusing now. Well, remember the properties of logarithms. Power rule. I can rewrite this as x times the natural log of 7 equals the natural log of 10. The natural log of 10 is just some number. Do it on the calculator. Natural log of 7 is just some number. So these are just numbers. Whatever number that is, I'm going to divide both sides by that number, and I get x equals the natural log of 10, whatever that is, divided by the natural log of 7, whatever that is. In other words, x equals, here comes the calculator, the natural log of 10, close parentheses, divided by the natural log of 7, close parentheses, and I get 1.18329 approximately. And just like we said, somewhere between 1 and 2, closer to 1. There it is. So what's going on here? Now notice I didn't have any logarithms, and I introduced the natural log here. Well, we can do the same thing if I had, for example, if I wanted to do find log base 2 of 11. Well, log base 2 of 11. I mean, what am I going to do here? Well, let's set it equal to x. Log base 2 of 11 equals, I don't know what it is. And then I'm going to solve for x. So all I did was I set this equal to x, and I'm going to solve for x. I'm going to rewrite in exponential form, which says 2 to the x equals 11, 2 to the x equals 11, and now look at what I've got. I've got something very similar to the problem we just did. 2 to what power is 11? Well, I know that 2 to the third power is 8, and 2 to the fourth power is 16. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. 11 is somewhere between 8 and 16. So x has to be somewhere between 3 and 4. But where? How do I solve this? And again, we run into the same problem here. We're going to do the same solution. We're going to take the natural log of both sides, and I'm going to get the natural log of 2 to the x equals the natural log of 11. And it seems like we're going backwards. Didn't we do all this work just to get it out of logarithms by rewriting it, and now we're going back again? The answer is yes. But why? Here is log base 2. On my calculator, I don't have a log base 2 button. So I rewrote it to get it out of log base 2's, and then I take the natural log, because I do have a natural log button, use properties of logarithms, x times the natural log of 2 equals the natural log of 11. And again, I want to emphasize, the natural log of 2 is just some number. We're going to do that on the calculator in a moment. The natural log of 11 is just some number. Divide both sides by that number, and I get x equals the natural log of 11 divided by the natural log of 2, which is, here comes the calculator again, natural log of 11, close parentheses, divided by natural log of 2, close parentheses, and I'm getting 3.45943 approximately-ish. Just like we guessed, somewhere between 3 and 4. 3.45. All right, so this brings us to, if we put these last two problems together, we've got a whole new formula now. And here it is, the change of base formula. If I have some sort of weird logarithm, log base a of m, well, I can rewrite it using properties of natural log, and this is the same thing as the natural log of m over the natural log of a. For example, if I have log base 7 of 41, what on earth is that? It would be log base, natural log of 41 over the natural log of 7, using this change of base formula. So on the calculator, if I did natural log of 41, close parentheses, divided by natural log of 7, close parentheses. And here, I didn't even rewrite it. 7 to what power is 49? Well, 7 to the first power is 7. 7 squared is 49. So it's somewhere between 1 and 2, closer to 2. And sure enough, there it is. 1.9083 something, something, something. Now, if you've got one of these newer calculators, it does already have a change of base formula. I can actually evaluate this directly on the calculator. Let me show you where it is. If you go to the Math button, and then all the things that are here, I'm going to go down until I get log base. Let's see, where is it? There it is, log base. Hit enter. And look what the calculator's given me. It's waiting for, it says the log, and it's asking me for the base and for the argument. So I'm going to put in the 7, and then I'm going to put in 41, and there it is, same thing. Now, if you don't have a calculator that's got this, that's okay. You can use this formula every time and get the exact same answer. All right, they get a little tricky, but as long as you know what this is, it doesn't matter how weird it's going to get. You're just going to do things on the calculator. Let's do maybe one more out of the exercise set. You have to do 71 through 77. Let's do something like number 76. 76 is a weird one. It says the log base square root of 5 of 8. Log the base of the square root of 5. Now, what a horrible, awful base that is, the square root of 5. Well, I know that I can rewrite it as the natural log of 8 divided by the natural log of the square root of 5. Now, I could use the shortcut on my calculator if I wanted to. Casio users, the newer Casios also have this shortcut. But again, I don't need the shortcut if I could do it like this. So natural log of 8 divided by the natural log square root of 5. So second square root of 5, close parentheses, equals, and I get 2.584, and I had no idea. The square root of 5 to what power is 8? I've got no idea at all. On some of these other ones I could guess. 7 to what power is 49? Well, 7 squared, 41. 7 to what power is 41? Well, 7 squared is 49, so it's going to be a little less than 2, and sure enough, there it was. Here, the square root of 5 to what power is 8? I've got no idea at all, none at all. But if I take this, the square root of 5 to the power of this would equal 8. All right, so that is 6.5, dealing with the properties of logarithms. This assignment can get very frustrating. These properties are counterintuitive. The answers in the back of the book don't always show you all the work that goes with them. This is one where often the next day in class, there's several ones that students have got questions to, and most of the time, if I just do the first 1 or 2 steps, either expanding or condensing and rewriting, those are the key steps: expanding, condensing, rewriting between exponential and logarithmic form. But I want you to go ahead and do the homework 6-5. Homework 6.5 is on page 465, and it is problems. I want you to do 13 through 49, the odd ones, and 57 through 77, the odd ones. And I've been talking about these as I went through the lesson, talking about, oh, this is what you're going to see in the homework, and this is this part of the homework, that's the other part of the homework. And when you're done with this, as always, I want you to email me the assignment. Please use either a PDF scan file or JPEG picture files, and email it to me at robert.shannon@gccaz.edu, the same email as always. And we start seeing homeworks should be coming in pretty soon, and you'll see the grades changing as I enter grades. Each of the assignments is worth 10 points. And what I do is actually I print off the assignments at home. I'm printing them off, and then I'm grading them, and then I'll be entering the grades. So each assignment's worth 10 points. There's 8 or 9 assignments, so it's about 100 points per chapter, just like the test would be. but these are more individual things now. And ladies and gentlemen, please with the homework, don't just copy answers out of the back of the book. If you're not going to do any work, you're not going to get any credit. So make sure that you're actually doing all of the work. I think I've said that before, and I want to emphasize that. And as always, if you've got any questions, just shoot me an email. Thanks, guys. I'll talk to you again soon.